Until you understand, we will explain it, no problem. Okay, don't worry.
Okay, sir.
Okay, so here we did till this part, right? Huh?
Yes, sir.
Okay, so uh, his measurements are I equals 4 amperes and V equals 14.8 volt, right? Isn't it?
Yes, sir.
And the reading of the thermometer at time t 240 seconds. We got it right. What is the reading?
41.5.
41.5. So 41.5. Read the thermometer and record the temperature in table 1.1. So this table we have to fill it up, right? This place. Did you write it here?
Yes, sir.
Okay. So Abir, Tamjid and
Yes,
Abir.
sir.
Yes, sir.
Yeah. Welcome to our class. Thank you for joining. You are a little bit late, right? To join. Hello, Abir and Tamjid.
Yes, sir.
Yes, you are a little bit late to join.
স্যার আমি 9/4 জয়েন করছিলাম।
Yes, I know, but that is also late, right? You are
স্যার I
supposed
was
to.
just 4 minutes late.
Huh?
না স্যার কিছু না স্যার।
So try to join on time. So you wrote it, right? You wrote it here. You taken the printout, Abir,
Yes, sir.
and you wrote it, the temperature.
Yes, sir.
Tamjid, you also wrote. Tamjid,
স্যার 1 মিনিট দাঁড়ান না দেখতেছি।
yeah, please write on your printed paper. That will be better. As it is related to graph, it's really necessary for us to do the printing before going to this part. So, Ted, why it is important to ensure the heating coil is completely immersed in the water? What you wrote about this? What you have written about this? Hello? Abir? Yeah, Ifaz.
Yes, sir.
You wrote anything here? Have you written?
Sir, I wasn't able to do this one. I was confused.
Yes, that's why I'm asking you. If you are confused and if you actually facing difficulties to get this answer, you should share it that yes, sir, I face difficulties. So Abir, and we all are here to share, right? Why the class is for discussing, right? To share the ideas, isn't it? So that our ideas are combined and we all are benefited from each other, right? Isn't it? Hello?
Yes, sir.
So we will do that, right? We will always share our ideas. If you know anything, then that one might be enriched my knowledge also, right? Isn't it?
Yes, sir.
So here, one thing we understand. Look, from this, statement, they are saying completely immersed in the water, right? If you keep this heat a little bit up of the water, what will happen? Hmm? Can you guess? Hello, you share your ideas. Share, please, because it's not like everything uh, always unknown to you. You know many things. Just you have to uh, try, then you can get it. It's not that difficult thing. Like if you were taking this heater a little bit out, completely not immersed in water, then what will happen? Tell me. Share your ideas. Hello? Yeah. Because
Uh, Sir,
if
it's lagging a little bit. Can you again say what
yeah,
you...
I'm saying again, no problem. My question was, if I take, or if we take the heater a little bit out of the water, then what will happen?
The temperature will not be properly measured by the thermometer.
Yeah, this heater. Look, they are asking about ensure state why it is important to ensure that the heating coil is completely immersed in the water, right? So if your heater is outside, like if you are taking the heater completely outside the water, what will happen? Will your water be heated?
No,
Why? Why it's not heated?
because the heater is out of the beaker, so it will
The
not be heated.
heat is out of the water. That means your water, the heat is not transferred to the water, right? Now, if your heater is like half in the water and half in the outside, then what will happen?
It will be heated half.
Yeah, it will be heated, but not, the way the heater is giving heat, all the heat will not be absorbed by the water, right? Isn't it?
Yes, sir.
Okay. So, so then, then finally, if we immerse it completely inside the water, then what happens? Our all the heat is absorbed by the water, right? Isn't it?
Yes, sir.
So, what can we deduce from this discussion? We can say that if we completely immerse it in the heat, completely immerse this heater or heating coil inside the water, then no heat is lost in the surroundings, right? Or in other way around, we can say all the heat is absorbed by the water. Is it clear now?
Yes, sir.
So what can we write here? Say
So that all the heat is absorbed by the water.
yes. Then after Ifaz, now I am going to Abir. Abir,
Yes, sir.
have you understood the discussion?
Yes, sir.
So have you written the point?
Yes,
Or
sir.
what you wrote, Abir?
So that all the heat is absorbed by the water.
Excellent. Amjad, have you
Sir,
written the
so that
point?
the yes, sir.
Yes.
So
What
that
you
all the
wrote?
heat is absorbed.
Yeah, all the heat is absorbed or no heat is lost in the surroundings, right? You can
Yes,
write any way, no problem. So you understood it, right?
yes, sir.
Yeah. Now, uh, second point, another point, very important. Can you read? Uh, Amjit, can you read this? Second point, please read. Amjit, hello, Tamjid. Okay,
Sir,
Abir. Yeah, Tamjid, you read it. Read this point. Yeah.
uh, stir the water before each temperature before recording each temperature.
Okay, so why why we are stirring the water before recording its temperature?
So that all the heat is transferred throughly in the water.
Yeah, or uniformly, right?
Yes,
So
sir.
that all the heat is uniformly distributed in the entire water, right? Isn't
Yes, sir.
it? This one is the main purpose of stirring. Otherwise, maybe the part where the heater is, that part will get more heat. The other part may be a little bit cold, right? Then the thermometer reading might not give you, appropriate measurement, right? Isn't it? Hello.
Yes, sir.
So you write it, then you tell me what you wrote quickly.
So that all the heat is uniformly distributed in the water.
Very good, very good. So what you wrote, Abir?
So that the heat is evenly distributed in the water.
Excellent. Then Amjid,
Sir, because it enables the heat to be distributed completely.
yes, awesome. So all are correct. Then we are going to the graph. Yeah, Amjid, continue this. C1.
On the grid in figure 1.3, plot the graph of delta slash degree Celsius y-axis against T slash S x-axis. Set the temperature axis at 20 degrees Celsius.
Uh, so they are saying we should plot theta, that is temperature, in y-axis and time in x-axis. And look, it's written theta slash degree Celsius. That means you should give this quantity and unit in the y-axis, 1 mark for that. Time in the x-axis with the appropriate unit. So to write, by writing this quantity and unit correctly, you are having 1 mark. Out of 4 marks, you are getting 1 mark. So it's very easy mark, right? To get. And
Yes, sir.
second mark is for scaling. Scaling means the values you have here for time and temperature. These values you should cover more than, at least more than half of the graph. The way the values you are getting, you should set the scale in a way so that the points will cover more than half of the graph, both the axes. And here we have one indications, one instruction that we have to start the temperature axis at 20 degrees Celsius. That means previously we started, so far we did um, three graphs, right? For practice paper 1, 2, 3. In all of them we had to start from zero, right? Hello?
Yes, sir.
Yeah, so this one is different. This one is saying to start the temperature from 20 degrees Celsius. So your temperature will start from 20, yeah? Not from zero. Is it clear?
Sir, can you show the scalings?
Yeah, I'm showing you. So from here, your temperature will increase 20 degrees Celsius, right? Then it will go onwards. We see the temperature is given how much. Now the graph is more clear, right? We can see the
Yes, sir.
big square and small square clearly. Look, the temperature scale is given till 48.5. That means it is 50, right? We should take from 20 to 50. So we take how many big square is here in our y-axis? How many? One, two, three, 4, 5, 6. Is it 7, 8? 8, 8, right? 8 big squares, isn't it? Hello? In the y-axis we have 8 big squares, right?
Sir, 7.
7 or 8? 1, 2, 3, 4, 5, 6. Let me check. Yes, 7. Okay. 7. Now on screen is tough to see because I made the screen bigger. So 7 you got, and here the range is from 20 to 50, right? Isn't it?
Yes,
So
No,
sir.
sir, it's 8.
say 1, 2, 3, 4, 5, 6, 7. No, in y-axis 7, right?
Sir,
B.
in x-axis 8.
Yeah, x-axis 8. I counted 8, but in y-axis we are first dealing with. So scaling of y we do first. So here it will be 20, right? At the beginning. So here you write 20.
Sir, should we give like a broken line? Because we're starting
Not
from 20.
necessary, not necessary to give broken line. It's okay that you starting from 20. 20, then we have here 30, 40, 50. So two big squares, for two big squares you will take 10. That means 20 small squares will be 10. Is it clear? So it will be 30 here, then it will be 40 here. This way you go. And another two big square, that is making 50. Is it clear?
Yes,
So
sir.
y-axis is clear. So our y-axis is covering 6 big squares. We have 7 big square. We are covering 6 big squares. So it's more than half. We we did it completely according to the rule. Then for x-axis we have time from 0, right? Is the time from 0?
Yes, sir.
Okay, so 0 to 360. So from 0 to 360, if you want to take for this 8 big squares, how can you take it? 360. So if we take here 100, 200, 300, 400, right? That will be nice, isn't it? 100, 200. So here is 100. You write here 100. Then here we have 200.
Sir,
Yeah, yeah. Tell me, Abir, you understood it?
sir, on the x-axis, can we take from 0, then 60, then 120, like that?
0 then
0, then 60, then 120, then 180.
0, 60. Actually, there is one rule in our plotting, that is called your uh, scaling. You can take like that 5, hmm, 5, 10, then 20, like this. If you take, for example, you are taking 60 here for big square, then your each of the small square is taking 6, isn't it?
Yes, sir.
So if it is getting 6, then when you will get the reading, if you see the reading are coming, then sometimes you will get awkward scaling. Then you have to face difficulty in getting the point values. That is called awkward scaling. Is it clear? Hello, like
Yes, sir.
uh, 3 is to 1, then 9 is to 1, then 7 is to 1. This way we don't prefer. That was called awkward scaling. In some cases, for this awkward scaling, you will lose a scaling mark. Is it clear? That's why you should avoid it. Now simply you see we are having this 100, 200, 300, then it's going till 360 here, right? So it's coming nicely, right? Isn't it?
Yes,
More
sir.
than half. More than half is coming nicely. So we can take this one easily, 100, 200. So it's clear to you? Yeah, it's also easier for you to calculate, to get the plotting points. If you give this type of scaling like 150, uh, like 10, 5, is easier, right? Isn't it? So
Yes, sir.
yeah, Abir, Tamjid, so Tamjid,
Yes, sir.
you understood the awkward scaling?
Yes, sir.
Okay, so you now plot, huh? You all plot, then you after plotting, you send me the diagram. Yeah. Send me the diagram in our group.
Sir,
Yes.
here you give that 100 to 100, but in exam, how will we understand that? What should we give?
Yeah, very good question. Like when I got the values, uh, you see, we have here 0 to 360, right?
Yes, sir.
So when I got 0 to 360, then I have my mind already. You told me that we have there 8 big squares, right? So if we have
Sir.
8 big squares, that means these 8 big squares we can easily take 400, right? Isn't it?
Yes, sir.
So 400, if you take, that's covering our more than half of the x-axis for these values given. That way, I planned that my two big square, if it is 100, that will fit for this graph best. Is it clear? This way I planned. You can also
Yes, sir.
make this plan in the exam. Just one thing you have to remember, that your x-axis and y-axis both are covering more than half of the graph or not. Is it clear? So
Sir,
now,
okay. Yeah.
okay, now you join after 7 minutes, and by this 7 minutes you finish the graph and send it to the group. Okay, 9:40 you join.